The question is, assume that the diode in the figure has V on is equal to 0.7 volt, which means the cut-in voltage is 0.7 volt for the diode, but is otherwise ideal, which means we have seen in large signal models of the diode, that is, the diode characteristics were like this, where this is the cut-in voltage 0.7 volts. If the voltage across the diode is less than 0.7, then the diode is modeled as an open circuit because the current flowing through it is zero or negligible. But when the voltage across the diode becomes 0.7 or slightly higher, then the diode is modeled as an ideal diode in series with a cut-in voltage 0.7 volts. But in fact, the ideal diode will be a short circuit in that scenario, and we have only the voltage source representation of cut-in voltage. Now the question is, for the given circuit, what is asked is the magnitude of the current I2 in milliamperes is equal to. The I2 is here. Now for the given input voltage of 2 volts, we want to figure out first of all if the diode will be in forward bias or reverse bias. So for that, let us first take a situation where, let's say, the diode is open circuit, where it is not taking any current. Then it will be very simple to understand. The reason why we are choosing that the diode is open circuit is the first assumption to start with for this problem is, if the diode is open and if the current is flowing through the two resistors, if the voltage across the 2 kilo ohm resistor is less than 0.7 volt, obviously the diode will be open circuit, in which case our assumption will be correct. If the voltage across the 2 kilo ohm resistor is greater than 0.7, then obviously that diode will be in forward bias, in which case we have to take this equivalent model and then solve the problem. To start with, we are assuming the diode is open circuit and then doing the analysis to figure out if our assumption is correct or not. So in this case, the voltage across the 2 kilo ohm resistor will be 2 volts times 2 kilo ohms divided by 2 plus 6, 8 kilo ohms. Kilo ohms cancel. So we get 4 divided by 8, which is 0.5 volts, which means the diode will be operating somewhere here, in which case the equivalent model is an open circuit, which means our assumption is correct, that the diode will be open circuit. Now given this, now the current that is flowing through the circuit will be, I2 will be equal to 2 volts divided by the total resistance here, which is 8 kilo ohms, which will be 0.25 milliamperes. So the answer is 0.25